Hi, welcome to Sensei Very. I'm going to lead us through the practical skills activity which you need to work on before the end of the year. This is intended to be a supplement to the things which we're covering in lessons. This may be of use to you. I'm not going to give you all the answers in this video. That wouldn't be useful. If you're unsure about any of the answers which you've given to your questions, come and find me. We'll go through it. We'll go through many of the answers to these questions in lessons anyway. So, let's go through the booklet, and we'll go through things in a logical order. The first page gives you some interesting things which are worth reading. Next, you're given some further interesting information about graphs, their utility in AS and A2 physics, and their utility in further study of physics as well. But what we want to know is what we need to do for the activities. Here's the first activity. You're given a series of relationships. These relationships are detailed here on the left. What you need to do is you need to determine what would be plotted on the y-axis to test this relationship, what would be plotted on the x-axis, what the gradient of such a graph would be, and what the y-intercept would be. You did a similar activity with me towards the beginning of the year, way back at the beginning of the year. Let's do the first example together. If you were plotting this relationship here on a graph and you wanted to test it, I'm going to change colour to something more visible. You would probably plot y on the y-axis, y being the thing on the left-hand side of this relationship. On the x-axis, you'd probably plot x. The gradient of such a thing would be minus c, and the y-intercept would be d. Do something similar for the other questions, please. This should be relatively easy. If there's any problems, come and find me. You're then told something about square roots. Here's a relationship which you're going to be studying at A2 if you continue to do A2. It's called simple harmonic motion. It has to do with the way in which things oscillate. You're asked to look at this relationship here, the second one, involving squared terms, and determine if you were to measure the time period and length of a pendulum and you wanted to test this relationship, what you'd plot on the y-axis and what you'd plot on the x-axis. What would the gradient be in such a case? You're doing a similar thing here to what you did in the previous exercise. Next question. You're given some data from engineering. You're told about a relationship which has this form. You ask how you plot a straight line to test this. It's very similar to what you did before. This is rather repetitive, isn't it? Oh well. You then need to fill in this table here to show what data you would physically plot on your graph. You're not going to be plotting just the length. You're going to be plotting something else. Look at the relationship here. You're not plotting D. You're plotting something else. What's that other thing? How can you get that other thing from D? Put that other thing in the second column of the table. Then work out the percentage uncertainty in the span, which is the length of the beam, and then determine the absolute uncertainty in whatever you put in column 2 over here. This will be useful to you. Okay, there's a challenging question down here at the bottom, which would be justified in working out a safe load from 6 meters from your graph. And why? Think about the concept of extrapolation. Think about how valid it would be to extrapolate in this case. Would it, or wouldn't it? Let's hear your thoughts. Next, you're given a past paper question. I think we've gone through this in lessons. It was in one of the specimen papers last year. You're asked whether this is a valid relationship which would describe the stopping distance of a motorcycle. Think about the equations for thinking distance and stopping distance which you learned at GCSE. One will be speed is equal to distance over time. One will be a Suvat equation. Combine the two together to get an equation for the stopping distance. Then given this question here, it should be relatively easy to solve this, having done the previous exercises. You're then asked to complete a table. You then need to combine some uncertainties to determine the uncertainty in d over v for that value which you put into the table. You're then going to plot the missing points. Now, to plot the missing points, you're not merely plotting points, you're also plotting these things called error bars. You plot error bars as such. You first plot the point in the traditional fashion. You then plot the highest point, which that point could be, and the lowest point that point could be, and you join the two by a bar. We'll call this an error bar. The width of the error bars will be determined by the absolute uncertainty in your data. Notice that the width of the error bars changes for different data points. Then you need to determine some y-intercepts and gradients, determine these things called A and T. And then you're given an interesting question. I'm not going to give you any help with this one. Here's a very similar question. You're asked to combine some uncertainties to determine some percentage uncertainties, and then to do the same again in this question here. You're then thinking about, if you were to test this relationship, what you plot on each axis, and what the gradient of the y-intercept would be in order to determine the value of these things A and B. It's a similar question to those which you've done previously. Again, if you have any trouble, come find me. Then there are some challenging questions here. particularly this one. Have fun with that. You're basically saying, if B is the y-intercept in this relationship here, what does B physically mean in terms of things like row L, A, and D? You'll need to rearrange some equations to determine the answer to that question. Next, you're told about power. You've covered this on the other side of the course. It's an interesting concept. You're asked to describe an experiment to test it. You know how to do experimental description questions by now. You mentioned the equation, which you're trying to prove. You mentioned the data you're going to take, the sources of absolute uncertainty, the equipment you will use, and so on and so forth. Determine what you'll do with your readings. Determine what graph you would draw. Tell me what the y-intercept in the gradient will be. Tell me how you'll be able to prove whether this law holds or not from your gradient and your y-intercept. Just follow the procedure you've been taught to solve this one. Then there's some data. You can manipulate this data in order to see whether you can prove this equation or not. And then you're going to plot a graph and you're going to see whether this power law, this equation, is correct or not. You're following a similar procedure to do this as in all the previous questions you've done. There are some other things to think about here also. Then a little bit of a reminder on combining uncertainties. All this is in your notes already. This should be something you know. If it's not, don't worry. Just recap it. Then you're told about some experimental apparatus to prove this relationship here. You're told about ideal gases. You'll study ideal gases at A2. They're quite interesting. You're given some data. You're going to draw a graph. You're going to test whether this relationship here holds. V is equal to KT plus V naught. Think about what you plot on the Y, what you plot on the X, what the gradient of the y-intercept will be. There's some interesting data here. You're then going to determine some percentage uncertainties in L and D. That's relatively difficult. You'll need to look at this information here. You'll need to look at what readings have been taken. You'll need to look at what pieces of equipment have been used to read them. You need to look at how many pieces of data have been taken. How do you determine the absolute percentage uncertainties with repeat data? Remember, or look back at your notes. That's how you'll solve this question here. You're then going to give your answers, and you're going to do some thinking. You're given some introduction about logs. We covered logs very briefly at the beginning of the year. If you do mathematics, you would have covered them in mathematics also. This may be of interest to you. There's some practice in writing out the logarithms of numbers to the correct number of significant figures. The rule for doing that is here at the top. The rule is also given in your notes from the beginning of the year. In this example, example 11, it deals with an experiment. We're going to do this experiment in class, either with me or with your other teacher, so I'm not going to cover that here. Here are some things about exponential decay. This is interesting. You would have studied this briefly at GCSE. Example 12 has to do with the experiment, which we'll do in lessons, either with me or again with your other teacher. Again, I'm not going to cover it here. Example 13 is a PAG. You will do this again with me or your other teacher. I'm not going to cover that here, but I will say that you need to understand everything which has been covered in the remainder of the booklet to do well at this PAG. It involves all the skills which you've picked up by working through this workbook. Good luck!